Now that we have our Pythagorean identities down, let's take a look at some example problems simplifying expressions using those Pythagorean identities. So here's our first example. Secant of x minus tangent of x times sine of x. Now we want to write this in terms of sine and cosine. That's always a good strategy to start with these. So looking at this expression, secant, I can rewrite that as 1 over cosine of x minus, tangent of x, we can write that as sine of x over cosine of x times, sine of x. Well, it's already in terms of sine, so we'll just write it, we'll make it a fraction. Sine of x over 1. Now, simplifying, we have 1 over cosine of x, nothing to do there, minus. Here, if we multiply, we get sine squared x over cosine of x. Well, we have a common denominator, so we can go ahead and combine the numerator. We get 1 minus sine squared x over cosine x. Now, this is where it helps to have this understanding of these identities expanding out to actually form how many different identities? There's 9 of them, okay? Now, if we think down here to what we've got 1 minus sine squared x in our numerator. Anytime you see sine squared or cosine squared, you want to be thinking Pythagorean identities. So which identity might this be? Well, if we look at the very first one, sine squared theta plus cosine squared theta equals 1. Let's see, could that somehow be rewritten to be represented like this? Right here we've got 1 minus sine squared x equals cosine squared x. So let's rewrite this as cosine squared x over cosine x. And we can reduce that, right? This cancels with one of the cosine x's up top, and we're left with cosine x, and we're done. All right, example number 2. Cosine squared x over 1 minus sine x. We just saw cosine squared x come into play in our previous example, right? So maybe we can just recall that, or we can go back up and look at the identities as we have them expanded out up here. Here's a cosine squared x again, just like last time. Well, that's the same as 1 minus sine squared x. That looks very similar to the denominator we have here. So let's try that. So cosine squared x becomes 1 minus sine squared x. 1 minus sine x. Well, it seems like maybe I'm stuck, but let's take a closer look at this numerator up here. 1 minus something squared. Well, 1 is a perfect square, and sine squared of x is also a perfect square. This is a difference of 2 squares, and we can factor that. We can't reduce it like this, but if we rewrite this numerator in factored form, then we can cancel something out, I think. So 1 minus sine squared x becomes 1 plus sine x times 1 minus sine of x. All that over 1 minus sine of x. And now all of a sudden, I have something that I can cancel, and I'm left with 1 plus sine of x. These are like puzzles. You're going to have to be creative. You may have some trouble recognizing when you're done at times. Okay, example number 3. This one is going to take some work. We've got cosine of x over 1 plus sine of x plus 1 plus sine of x over cosine of x. Now this one, it looks like we're going to have to use, I'm guessing based on the 1 plus sine of x here, maybe we'll have to use a Pythagorean identity. Let's start by combining these into a single fraction. Now we don't have a common denominator, so in order to get a common denominator, I'm going to multiply this side by the denominator over here over itself. So 1 plus sine of x over 1 plus sine of x. We're just working to get a common denominator. And on this side, I'll multiply by the denominator over here over itself, cosine of x over cosine of x. All right, so let's see what we get. Up top, in our first expression, we have cosine squared of x. On the bottom, we have cosine of x times the quantity 1 plus sine of x, and that is our common denominator. Right, we'll have that same denominator over here. We have cosine of x times 1 plus sine of x. Up top, let's see, we're going to have to FOIL, okay? 1 times 1 is 1. 1 times sine of x is sine of x. Sine of x times 1 is sine of x. And sine of x times sine of x is sine squared x. We have our common denominator now, so we can combine the two numerators. So we have cosine squared x plus 1 plus, we're going to go ahead and combine like terms here. This becomes 2 times sine of x plus sine squared of x. All that over cosine of x times 1 plus sine of x. Well, I see these two squared terms. I've got a squared term here and a squared term here, and I'm thinking Pythagorean identity. And remember, the most basic one we learned, sine squared of x plus cosine squared of x equals 1. Well, I've got sine squared of x plus cosine squared of x right here. Those are going to cancel out to become 1. That 1 right there. So let's rewrite this one more time. We now have the 1 that we just got by canceling out cosine squared x and sine squared x, plus the 1 we already had right here, plus 2 times sine of x, all that over cosine of x times 1 plus sine of x. Now at this point you're probably going to start getting sick and tired of rewriting this denominator over and over again, but stick with it, rewrite it every time. If you get lazy and try to skip steps, you're going to lose track of something along the way and you'll end up with the wrong answer. Up top I can simplify a little bit further. I can combine like terms again. I have 2 plus 2 times sine of x over cosine of x times 1 plus sine of x. And hopefully some of you are starting to see the light at the end of the tunnel here. We're going to factor up top. We've got a GCF of 2. So let's factor that. That becomes 2 times the quantity, 1 plus sine of x. And boy, that looks encouraging because I've got one of those in the denominator, don't I? Cosine x times 1 plus sine of x, and finally something I can reduce. 1 plus sine of x cancels with 1 plus sine of x, leaving me with 2 over cosine of x. Now that looks pretty good, but I really don't like that fraction. So let's see if there's some way that I can simplify that even further. I know the reciprocal of cosine of x is 1 over secant of x. So let's try that. I plug in 2 over 1 over secant of x, and then keep change flip, right? So here, I'll actually write this a second time. This equals 2 times the reciprocal, we're flipping here, secant of x over 1. Well, I don't really need the 1, and I can just end up with 2 secant of x.